give some examples that I think are really interesting. And as I mentioned, I did, my background is mechanical engineering before I came to Harvard, and then luckily I was able to go to NASA Johnson Space Center and work with the dexterous robotics team in summer of 2022. So this is a picture of me next to a couple robots. So the left robot is Robonaut 2. This was developed in partnership with NASA and GM. It was really just a technology demonstration. It didn't really do actual work, but it was really good for technology development. And on the right is Valkyrie. So Valkyrie is NASA's first bipedal humanoid robot, so it's able to walk on its two legs. And since then, there's been a lot of exciting progress that I want to talk about. So really, what does AI mean when we talk about robotics? It's really about physical intelligence, and that's what I think distinguishes AI and robotics from a lot of other types of AI, in that there's a new physicality that really matters. And so this is just a few examples of how we can use AI in robotics. We can use natural language processing for interfacing between the human and the robot. We can use machine learning for object recognition for the robot's perception system. And finally, we can use AI in the control systems. So we can develop machine learning-based controllers that perform better than the traditional sort of model-based. And so also I want to emphasize that AI is really just a really overarching term. So when we say this, it can mean a lot of things in robotics. So within AI, we have machine learning. Within that, we have deep learning. And in robotics, we use all types of these. And so as an example of a really interesting humanoid robot, I want to show some videos. So this video is Tesla's humanoid robot. It's called Optimus. And so I just want to show. Sorry, sorry about that. So this is just one example. So this was released in December 2023. Most recently, they have Optimus Gen 2. You can see here doing a lot of really fluid movements, bipedal walking, dexterous manipulation with tactile sensing, manipulating delicate objects such as eggs. So it's really interesting to see what Tesla is doing. And then Tesla's not the only player here. There's a lot of companies. Next, I want to talk about Atlas. This is robot is from a company called Figure. It's their Figure 1 robot. And this demo I want to show because it shows the end-to-end system for speech, human speech to robot control. So here in this video, essentially the human will say something like, just can you describe your surroundings? What do you see? It'll say, I see an apple on a plate, I see a cup, and it can, then the human essentially asks the robot, okay, can you give me the apple, or can you clean up, essentially? So the point is that the human here is giving the robot these really high level commands, and the robot is trained to take those high level commands and map those to motor actions. So this is, I think, one of the most impressive examples of AI, and this is also enabled by large language models, such as in that this company here partnered with OpenAI to make this system. And again, this is impressive also in the dexterity of the fingers. So the dexterous manipulation here has always been a really big challenge in the field of robotics, and so to be able to from Boston Dynamics. And the reason I show this is because it shows another level of physical performance that I think we should consider when we make robots, in that robots can perform better than humans. We don't need to constrain ourselves by limiting the robot's capabilities to that of human. And you see that here, in that the robot can turn its head completely 180 degrees, it can turn its torso 180 degrees, and so you can see how this can really give us new capabilities in the future. And so, so as I mentioned, all these robots use AI. Some people, but AI is such a general term that it's really helpful to talk more specifically. So first of all, the large behavior models, such as in the figure 1 robot that I showed, those are what enable human voice commands to be mapped to robot joint state. So this is using large foundation models that were enabled after the advent of ChatGPT and similar technologies that really give us really new capabilities. And additionally, it's not only in the sort of language intelligence, but also in the physical actions that the robot can perform. AI gives us new capabilities. So you may have heard of reinforcement learning. It's a type of machine learning that robots, that's becoming really popular and really useful in robotics. Essentially, instead of using model-based controllers, we can train neural networks that function as a robot's controller, and the robot can learn these over time and even learn, adapt its controller over its lifetime so that it can adjust to new environments and things like that. And so these robots are really cool, but they're not really useful unless people want to buy them, unless there's a market for them. And the reason that all these humanoid robot companies are springing up at this time is that the technology is there, and also there's a demand for them. So right now, Mercedes-Benz is partnering with Patronic. It's a humanoid robot company I didn't show, but they're partnering with them to test their robots in their factories. BMW is partnering with Figure, and of course Tesla is working on Optimus. So the idea here is that these car companies, they presumably have a lot of data on their human workers working in their factories, and if they can use more robots, they can enable more productivity and things like that. Secondly, warehouse and logistics companies are big consumers and potential buyers of these robots. Amazon is partnering with Agility Robotics, which is another company I didn't show, but this is Agility Robotics manufactures another type of humanoid. And so, as you know, car factories and all types of factories use a lot of robotics already, so this is not too new in that sense. But even in this video, you see humans in the background welding with the robot welding as well. So if we can make robots do more of these tasks that they weren't able to do before, this is why we're pushing for humanoids, and not necessarily a human form factor, but the idea is that a humanoid robot is best fitted to do the tasks that humans do. So, secondly, there's a lot of tasks that are really simple to humans, but they're really hard for robots. So things like buttoning your shirt, folding clothes, tying shoelaces, these are really hard for robots because they require manipulating soft materials and soft goods, and they require a lot of dexterity in doing so. So this is a grand challenge, which I believe is still an open problem. A lot of people, companies and researchers are working on this. But I think in the future, we'll see a lot of progress towards these areas. And so, as I mentioned, humanoids, I don't think they need to replace human workers one-to-one. I think there's a lot of reason that there might be some fears that these humanoids are scary and they might replace humans and take all our jobs and get out of control. But really, if they can enhance productivity for the worker, there's reason to believe that humanoids can actually be good for us, and then increasing employment, increasing productivity, and overall being good for society. But But with all that being said, there's still a long way to go for robotics. And this video I want to show because it highlights 2 points. One is that robots can still mess up. So here, the robot spills the person's drink. This is a robot bartender. And secondly, it highlights that when robots are in positions of interfacing with the public, then they're held to higher standards. And when they mess up, it's worse because videos are taken and it goes viral on social media. And I think that when robots are working behind the scenes, like in factories or in other places, that's when we'll really see their potential. Because they will mess up, because they're machines, and especially if they're based on AI, we know that sometimes these neural networks can mess up in ways that are unpredictable. So I think that maybe we'll see the robot bartender one day become mainstream, but I think the more reasonable and more recent future, we'll see humanoids more so working behind the scenes. But having said that, so the robots I talked about previously, the humanoids, they're mostly about producing goods in factories, producing cars, or producing or moving items in warehouses. But there's a whole new class of behaviors that robots are learning, and these are unprecedented in their capabilities. This video I'm playing is from Toyota Research Institute, and they have an office in Cambridge that works on dexterous robotics. So here is Russ Tedrick, a professor at MIT and VP of robotics at TRI. But the point here is that robots are learning these new capabilities that are not that were not possible before, because these new capabilities involve manipulating soft materials, doing tasks that cannot be programmed explicitly, and that the specific tasks are things like making food, putting away dishes, really simple chores. But if these can be done reliably, we can see how this will unlock a new suite of potential jobs for robots. And so I think that I don't know when this will become mainstream, but it's clear that there's exciting progress here. And the specific technology that enable this are what's called large behavior models based on behavior cloning. So the way it works is a human operator will sit at a station and basically teleop the robot. I think it's here. So this station here, the human operator basically teleops the robot using some controls, and the controls have force feedback, so the human operator can sense the forces that the manipulator has, and then they collect all this data and essentially use that data to train the robot to then perform the task autonomously. And this part is showing these tactile sensors that these robots are employing. And so this is a new era of robotics that is really on the cutting edge. And so Toyota Research Institute and a lot of other institutions are actively working on this problem because it offers a lot of potential benefits. And so having said that, if I could give any advice, there's a couple of classes at MIT that I enrolled in. I cross-registered, but actually the materials are available online for free for anyone to access. And these classes are called Robotic Manipulation and Under Actuated Robotics. They're both taught by Russ Tedrick, coincidentally, who's also the VP of Robotics at Toyota Research Institute. But they're super helpful, and I really learned a lot through these, and it's a really exciting time to be a roboticist now because of all these up-and-coming technologies. And before I go, I also wanted to say that it's really easy to make impressive robot demos when they're just on video. And when you're in person, it's a whole different thing. So there's some ways to sort of detect that and some clues. So if you see a robot video that has a lot of cuts, if the scenes are constantly cutting in and out, it's not necessarily meaning that it's fake, but it could. But if a researcher is making a video and there's a lot of cuts, it could imply that the robot wasn't able to do the task in one go. Similarly, if the video is sped up at 2x or 4x speed, it could imply that the robot is slower than the video shows. And so just be aware of these things. Lastly is teleoperation. So it's really easy to get smooth robot motions and good performance if there's a human sitting behind the camera that's controlling it manually. And so this is harder to detect now with increasing robot performance, but be aware that this is possible. So one way to know, also judge whether video is legit is if it's based on the source. So institutions like Toyota Research Institute, and if you can track the research papers behind these videos, that also give you more insights. But that concludes my presentation. I wanted to give you an overview of robotics, and thank you. And if you